Hi, I'm JD, and this is the first in a series of videos I want to talk about a robot that I want to make. So recently, Matt Denton made a Spoolbot out of a 3D printer filament spool. I don't have one of those, but the project was quite interesting, and I wanted to try doing it. He uses nickel metal hydride batteries because he wanted some weight to it, and I don't have any of those. What I do have, though, is a 12-volt lead acid battery, which has a lot of weight to it. And so I wanted to see if I could make a robot around one of these. So I've ordered some parts like 12-volt motors and some motor drivers. And so in the beginning of these videos, I want to show how I explore these new components and see if I can make my own version of a Spoolbot without a spool. So my plan for this video is to show a motor carrier board that I bought for the project. I've not used it before, so I got to try to figure it out. So for that reason, I'm going to use a motor that I'm more familiar with. These run on 5 volts, so I'm not going to use the lead acid battery just yet. But I'll write a program with the Uno to be able to change directions and change speeds with this motor carrier board. I also plan to contrast it against the L293D, which I usually use or have used in the past, and see, hopefully, that there's a difference. So I bought a bunch of parts and motors, and one thing I wanted to try using is some motor controllers. And so today, I'm going to open up some motor controllers that I bought. So let's have a look. So the reason I'm using motor controllers is because, if you have a microcontroller like an Arduino, it cannot supply the power needed for the motors. So I wanted to try these. So I haven't actually opened this, so let's just see what we get here. So here's the invoice, and here are 2 little foil envelopes. Okay, so why don't I move the camera and then we can have a look at these together. So let's see what they give us here. There we go. So each of these has header pins and then a little board. All right, so just for comparison, this board's quite small actually, and this chip right here, that is the MP6550, and then it's got capacitors and transistors and everything on the back very nicely. All of the pins are labeled, so the inputs here, which would be on the left side, the input and the output to the motors, okay, and some other pins here. But luckily, one good thing about buying from like a known brand is that there's good documentation, right? So I'm going to look up on a data sheet about this pin and this board and get a better sense of how I'm going to connect the battery, how I'm going to connect the motors. Okay, there's a 3.3 voltage out pin, which is good that this can run on 3.3 volts. Or that's a good thing to know. Okay. So yeah, I'll have to do some reading and get a better sense of how it is I'm going to use this with a microcontroller. So that brings me to this. So here's the motor driver, okay, that I'm wanting to investigate. And because it's at 3.3 volts, I'm using a logic level shifter. Let me just turn that way. So my intention is to have this side powered at 3.3 volts. And then for my motor, I'm going to run it at 5 volts. So this is 5 volts, and then this one is 3.3 volts. And this is my breadboard power supply. Okay, so I can keep the 3.3 volts separate from the 5 volts, but the 5 volts here will power the motor and not my Arduino. I don't want my Arduino powering this motor. So what else is on here? Oh, so there is a potentiometer. So my program that I put on here will read the potentiometer. Let me just put a little knob on there so I can turn it. And that will change the speed of the motor. And then this, if I press it, the power will briefly stop and then it'll change directions. Okay. So there are 2 ground pins on this board. So I've connected both to ground. This pin here, pin 6, this is pin 1, here's pin 6. That's the sleep pin for the H bridge. So I've put a 10 kilo ohm resistor. I just arbitrarily chose that one and put it to the 3.3 volts to bring it high. Okay, so let's wire this up. So definitely I want to connect the ground lines of my Arduino to my circuit. These 2 grounds are already connected, but now the Arduino is connected to them as well. To read this potentiometer, I'm connecting it to analog A0. And then for my direction button, I'm going to go to pin 3. Just arbitrarily chose that one. So it's going to be an input and pulled up so that when the button connects, it'll pull it low to ground. Okay. And so then for my logic level shifter to go between the Arduino, or the Uno, and the carrier board, I'm using a PWM pin 5 with yellow on the 5 volt side, and then on the yellow on the 3.3 volt side, I'm going to one of the inputs. And then my next PWM pin, pin 6 in blue here, going to the logic level shifter, and then blue on the 3.3 volt side to input 2. Okay, I want to power the motor with 5 volts. So I want to put this to the V-in pin, which is 5 volts here, to pin 12 here, pin 12 of this board. Okay, and the last thing is the motor. So these are going to be the 2 output pins. Okay, looks like my ground fell out here. Okay, let me just turn this down here. Okay, so now I've wired everything up. So let me plug in the Arduino. Okay, and now let's plug in the power. I'm thinking the motor won't run yet. Okay, good. So if I turn the knob, the motor should start turning. Okay, and then full speed. Okay, so the way that's done is one of these PWM pins actually goes low and the other one then starts pulsing, and then the wider the pulse, the faster it goes. Okay, and if I press this button, it goes the other way. Okay, so the other direction. Okay, so with a microcontroller and this motor driver, you can control the speed and direction of a motor. In this case, we have a logic level shifter, but that's just because that runs on 3.3 volts. One thing I want to show you is that's full power through the motor driver. And then if I actually just power directly from the power rail, it's very similar. Okay, so there's not much power being lost through the motor driver board. The other thing I can do is actually just show you with a multimeter. Here, let me just turn this light off. So here, if I bring my multimeter on DC voltage and connect to ground. And just to show you, this rail here is 5 volts, okay, 5.0, and this one is 3.3. Okay, and if I connect the motor, so again, the power rail is 5.0, and this white pin, this white pin, when I read the voltage, it says 4.95. So really not much power is lost through the motor driver to power the motor. Okay, so I just wanted to show that. So it doesn't really waste a lot of power. So by way of comparison, I wanted to show this. This is the L293D. So this is a very common through-hole microcontroller IC. It can control 2 motors. Here I've just connected to one side. These only control 1 at a time. It does work at 5 volts, so you'll see there's no logic level shifter here. But I wanted to show something very similar to the other setup. So let me just turn this light off here so I can bring in my multimeter. Here's my motor, so I'm going to connect the motor to the output. Here, let me wait on that. Okay, so let's start up the Arduino. Okay, that's going, and now both of these are 5 volts. So let's plug that in. Okay, in fact, here, let me show you. So if I connect to ground, this rail is 5 volts, and that's supplying through this jumper here. It's applying to the voltage from the motor. This side is also 5 volts. Okay. So let me just stick that somewhere random. So the Arduino is going, so let me hold on to this motor and plug it in. So what's happening in this is similar to before. We're reading this dial, and then we're sending a PWM signal to this first pin here. And then this yellow and this green are just digital pins, and if they help control direction. So if I press the button, that goes the other way. Okay, but you'll notice that it is actually going slower than the other one, the other motor driver. So like I said, it's 5 volts, 5.0 volts, but the output on this motor is well, that says 1 volt. That's not right, but it's higher than that. There. Just keeps coming up. So that's about 3.9 volts. So we've lost some power through this motor driver. So it's not as efficient. It's easy because you can control 2 motors and you can use 5 volts directly if you're using an Arduino, but you do lose some of the power. Okay. I just take this out, plug it right into the power. You can see it goes much faster. Okay. Okay, so I just want to conclude by clarifying the connections. So here's the motor driver carrier, and here I'm trying to draw it out. Please admire this for a moment because I drew it in Word, and that's such a pain in the butt. But if you look at the 2 ground pins, the pads are actually square, and so those would be both connected to ground. They're connected internally, but I connected them on my board, both to ground. this is the sleep for the H bridge, so that I connected to a 10 kilo ohm resistor to the 3.3 volts, right? So the high. Okay. This one I did not connect. These two I'm not really interested. Actually, this one is disabled on the board as is. These I weren't interested in. This one was, I'm going to connect to my 12 volts. Okay, and so that's the motor supply voltage. Okay, and then these are the two inputs. Okay, so either I had input 2 low and then did the pulse wave modulation at 3.3 volts. Okay, this is at 0 volts. Okay, and so then that would make the motor spin one way, right? So our motor is connected here. Sorry, I forgot to draw that. Okay, so then the motor would spin one way. The width of these pulses, so if you made them wider, up, down, okay, up, down. If you made them wider, then the motor will go faster. Or if I bring input 1 low and then did pulse wave modulation on input 2, then the motor would spin the other way. Okay, so that's how I connected this board in this previous layout. Okay, so I hope that helps. In the next video, maybe I'll quickly go over the programming I had on here to do this with the buttons and the potentiometer. And then after that, I'll actually break out my new 12-volt motors. Okay, so stay tuned for those videos, and I'll see you in the next ones.